for day 6, video number 2, I talked about how when there's an altitude drawn to the hypotenuse of a right triangle, technically there's 3 similar triangles that you'll see in the picture. There's the one on the left, the one on the right, and the whole big triangle. In this case, on the first video of notes, we talked about how you can draw triangles that are similar to each other, have them facing the same direction, and set up proportions. In this case, I'm going to talk about how you can use a formula to achieve the same result. So if we're talking about the altitude in a triangle, the altitude, when it comes down to the hypotenuse, splits the hypotenuse into 2 parts, part 1 and part 2. The formula to set up the proportion is that you're going to put the altitude in the means position of your proportion. Remember, that's the uphill diagonal. And you're going to put each of these parts in the extremes position, or in the downhill diagonal. And that would be the formula that we would use. If, instead of talking about the altitude, we were talking about either of the legs, in this case, I'm just going to reference this leg. Our proportion would be that the leg goes in the means positions, the same thing, fills in both places. The part of the hypotenuse closest to that leg goes in one of the locations, and the whole entire hypotenuse goes in the other location to fill the extremes position. So if you do not want to draw your triangle separately, you do have the option of using those formulas. The formula that you're using depends on whether you're referencing an altitude in case 1 or either of the legs in case 2. So when I look at question 3, I can see that we're referencing the leg over here. So I'm going to use the formula that deals with the legs, the part of the hypotenuse closest to that leg, which in this case is 3, and the whole hypotenuse, which in this case, if I add, gives me 10. So when I set up my proportion, I'm going to have a 3 and a 10 and a y and a y when I substitute in the information that's given. And then from there, I'm going to cross multiply and solve, which gives me y equals plus or minus the square root of 30 when I square root both sides. And we know we can only use the positive square root of 30 because we can't have a negative length. For a question like number 4, this has to be a right angle, by the way. This is the altitude that we're referencing here. So that means that I know that I am using the formula that has the altitudes in it, and it uses part 1 and part 2. So I know when I set up my proportion, the x is going in for the altitudes. I have 2 parts. The 3 is part 2, and then I have another part over here which I'm not given. But I do know that the whole thing is 15, and part 2 is 3, so that means part 1 is going to have to be 15 minus 3, which is 12. So the other 2 parts that get filled in are going to be 12 and 3. Cross multiply to solve. We know we're going to get plus or minus the square root of 36. That gives us 2 answers, plus or minus 6. We know we only want the positive one because it is representing a side length. For question number 6, we're dealing with the altitude again here. So my formula deals with the altitude, part 1 and part 2. And when I go through and fill in, the altitude is 6, it goes in twice. Part 1 is x plus 5, part 2 is x. I'm going to cross multiply to solve. So this is x times x plus 5 equals 36. X squared plus 5x equals 36 when I distribute. And I can see that this is a quadratic equation. In order to solve this quadratic equation, I need to get the equation equal to 0 so that I can factor set each factor equal to 0, and I end up getting -9 and +4. In this case, the +4 is my answer. The -9 gets rejected because you can't have a negative side length. In question number 8, I'm dealing with a leg. I know if I'm dealing with a leg of the triangle, the leg goes in 2 locations. The part of the hypotenuse closest to that leg goes in one spot, and the whole hypotenuse goes in the other. The whole hypotenuse in this case is 2x plus 5. It's what I get when I add the 2 parts together. So when I go through now and substitute in, the leg is 12. The part of the hypotenuse closest to that leg is 5. The whole hypotenuse is 2x plus 5. I'm going to cross multiply to solve. So I get 10x plus 25 equals 144. I'm going to minus 25 from both sides. So I end up with 10x equals 119. Divide by 10 and I end up with 11.9. The other 4 problems that you see on this page that I am not doing at this time, I will come back and do in a third video. That third video is optional.